Today I'm explaining how to do question 3 for the midterm number 2 project. So for part A, you need to set up your free body diagram, and you can do it for the whole system or for each block. And I just did it for the whole system. And so for block 2, the tension force, or there's tension force from the string, and then the gravitational force is pulling downwards on the block. And then for block 1, which is on the ramp or on the incline, there's tension force from the string, again here. And then because block 2 is heavier than block 1, you know that block 1 is going up the incline. So the friction force is going against the way the block is going. That's why the friction force is going this way. And then there's normal force because the block is resting on a surface, and the normal force is perpendicular to the surface of the ramp. And then there's gravitational force, but I broke that into its components of mg cosine theta and mg sine theta. And then I made this my positive direction, this my negative direction, and then this my positive direction, and this my negative direction. So then for part B, I started with block 2 because it was simpler. So you know that F equals ma, and for block 2, the F is the mg minus t, which is where this came from, equals ma. And then I just plugged in m and g, and the mass of block 2 is 5, so I plugged in 5 there also, which is where you get 49.05 minus t equals 5a. And then for block 1, F equals ma again, but this time the F is t minus mg sine theta minus friction, and so equals ma. And so then I just plugged in this for mg sine theta. So m is 1, g is 9.81, and then sine theta, and theta is 30 degrees. Minus fk plus t equals a, and it's just 1a because the mass of this block is 1 kilogram. And so next you have to solve for friction. And for friction, you know that the force of friction is the coefficient of kinetic friction times normal force. And you also know that normal force is mg cosine theta because here they are equal to each other, and they cancel each other out because the block is not moving in this direction. It's only moving in this direction. And so I plugged in mg cosine 30 for normal force, and I just multiplied that by 0.25, which is the kinetic friction coefficient, and you get 2.124, which is this force of friction. And so then you can set the equation F equals ma, or you can add these two equations together. And when you add them together, tension cancels out, which is how you're going to be able to solve for acceleration. So after you subtract 4.905 and 2.124 from 49.05, you get 42.021 equals 6a because you add these. So your a is, or your acceleration is 7.0035 meters per second squared, or just 7 meters per second squared. So then you use that acceleration to answer part C. But for part C, the tension is not, it's not just F equals ma. It is, but for tension, you know that you have to, so it is F equals ma, but the force is mg minus t equals ma, which is how you get to this equation right here whenever you just algebraically rewrite that. So then I just plugged in 5 for the mass, 9.81 for the gravitational acceleration, and then 5 for the mass, and then this is your acceleration that you found in part B. And that is how you get 14.03 newtons as the tension, as the magnitude of the tension in the string.